Hello, this is Mr. Bauma, Loyola AP Environmental Science, and this is a screencast tutorial for the rule of 70. If you wanted some review or for clarification on this rule, you should listen to this tutorial. Now, the rule of 70 is an equation that helps us make a lot of calculations. If you recall, we know that exponential growth is very powerful. We get this curve called the J curve. And an equation that will describe the accumulation under this curve is the rule of 70. And as Mr. Gore explained in class, money managers might call this the rule of 7, where money doubles in some regular fashion over time with some average percent growth rate. And of course today he used the 10% example. Long-term averages, 70 plus year averages over time shows that money will double at a certain rate in the marketplace. Alright, so let's just reiterate what the rule of 70 is. So the rule of 70 tells us the doubling time, and this is in years for us already, and that it is equal to 70 divided by the percent growth rate, and that's also yearly. Now, this is a quick shortcut equation. We don't have to move any decimals. We don't have to convert any units. We just have to remember that we plug in years or we plug in growth rate to get years. Don't have to move a decimal. So let's take the example that Mr. Gore gave. Call this example number 1. That assume you can get a 10% return on your money, and that's an average return. The question might ask, well, how long will it take for your money to double? Okay, so the question doesn't ask how much money is in the account. It doesn't ask how much money will be there later. This is just telling you in years whether how long it will take for whatever's in there to double. Again, we're going to apply this to human populations shortly. So if doubling time is equal to 70 over the percent, I simply put in the number 10. Again, no decimals needed to be moved. 70 divided by 10 is 7. And whoops, it's not percent. Careful. Doubling time is equal to 7, and remember doubling 7 is in years. Alright, so that's an easy one. So imagine your money doubling every 7 years. That compound interest is powerful, and Mr. Gore talked about it being a life lesson. The earlier you learn it, the sooner you begin to climb this exponential growth curve and you get closer to the J. The power of exponential growth is really hitting that J curve where you get an acceleration. In this case, earnings, money, the interest just compounds and grows. So hence his recommendation to learn to save and invest early so that you can hit the J early and have powerful compounding interest of money. But again, we're applying this to the class, and there's a lot of things out there that are growing exponentially and those that are not. They're growing linearly. And exponential growth, if it's the population, or if it's a problem like trash or waste in landfills, if it's growing exponentially, this is a problem we have to deal with. Alright, I'm going to do 2 more examples on the next screencast tutorial.